Hi, hi, hi everyone. Good morning, guys. Very good morning, all of you. Audio both are clear, everyone. Audio both are clear, everyone. Right. So here, everyone clear or not? So now we'll be continuing our discussions on this. That highway quick revisions, right? This quick revision series we are continuing now, right? Yesterday, what is that we have done? Right. Yesterday, what is that we have started? If you just remember, we have started this. Uh, which topic we have started, you can say, right? Horizontal alignment we have started now. Now we'll be continuing with that horizontal alignment, you can say, right? Yeah, Rishikesh, good morning, all of you. Welcome to Unacademy. Let's crack it, right? What is the referral code you have to use, right? RP Civil is the code you have to use. Yeah, Pavan, good morning. This is my profile, you can follow me at which, and this is the referral code you have to use, right? Yeah, Zamin Bhatt, hi. Now these are all 7 rankers, right? Those who got secured AIR 1 in GATE 2024, you can say. And this is a new batch starting on March 30th. That is fluid mechanics on March 30th at 5 p.m. by Jaspal sir will be starting. What is the referral code you have to use? RP Civil. And Sangram batch also will be starting on which one? This March 30th for this 2026 batch. Don't miss this, right? These placements batches also will be starting on 30th. So these new batches will be starting on which one? This is 30th March, right? This flat 50% offers are available up to a limited period only. Don't miss them. When you are taking Iconic subscription, you'll be getting all these books printed to your home address within 15 days of your subscription, you can say. Now, no cost EMI option is available at that too with 0% interest on your EMI, you can say. Okay. Now, these are all left side features are the ones we will be getting for which one? This plus subscriptions, and the right side along with the plus subscriptions it will be getting these additional features for this Iconic subscription, you can say. Okay. Now these are all gets over now. Which chapter? Like that, these are all over cross section elements and all these things over now. Geometry design, we have started this. Side distances, overtaking side distance, third chapter, right? Visual aids and all these things for this fourth chapter. Right now, what is that fifth chapter? You can say, if you just observe that fifth chapter is your horizontal alignment only, no? Yes or no? What is that fifth chapter? You can say this is your horizontal curves, you can say, right? So this horizontal curve got completed now. Yes or no? This horizontal curves got completed, you can say, if you just observe, right? Next. Everything regarding this we have discussed now. This horizontal curve, right, everyone, right? So this is 85, 88, 90, 92 up to this extra width also we have done now. Yes or no? Chapter 6 extra width also we have done, right? Now here up to which one it is done? 98 it is done, right? Chapter 6 now extra widening. Extra widening is your chapter 6 done. And now coming to this today's class, right? It is lecture 8, that is quick revision of this heavy engineering horizontal alignment part 2 we are going for, right? On this 26th of March. Now here what is that? Is it chapter number visible? Chapter 7 curve resistance, you can say. What is it? Chapter 7 curve resistance, that is your 98 are there now. Yes or no? 98 are there. So we'll be going for which one? This is 99 also. So 99th formula will be going for 98 only completed, right? Yeah, 99. So what is that? Curve resistance for front engine vehicle. Whenever you consider this curve resistance, right? What is the meaning of this curve resistance? It is a loss of engine power or this a loss of tractive force on the curve. Curve resistance for which one? Front engine vehicle. Whenever it is a front engine vehicle, right? What is it you can have? Curve resistance for this front engine vehicle, what is that you can say? That curve resistance is equal to power produced minus this power utilized. that is total will be equal to total loss will be equal to 0 na? Because how much you are producing the power, right, that much amount of loss only will be there, right? So sorry, how much you are producing, that much utilization is there, right? Complete utilization will be there, right? Now whenever it is a rear engine vehicle, what is it for this rear engine vehicle? That curve resistance is equal to that P minus this P cos theta, or you can also write it as this P into that 1 minus cos theta, right? That is your curve resistance expression, you can say, right? But in terms of this attractive force, if you are using, that curve resistance will be equal to that T into that 1 minus cos theta, na? 1 minus cos theta, you can say, right? Tell me why there is a loss in the rear engine vehicle, right? Why there is no loss in the front engine vehicle? Tell me why there is a loss in the rear engine vehicle and why there is no loss in the front engine vehicle. Tell me what is the reason for no loss in the front engine vehicle? What is the reason? Tell me, anyone? Reason for this front engine vehicle and this reason for this rear engine vehicle, right? What is that? Tell me. Front engine vehicle is not having any loss, right? But rear engine vehicle is having these losses, right? So what is the reason for this? Tell me, if you just observe. Because the direction of this vehicle movement and this direction of this engine power both are different here, right? Because of this change, that loss has occurred, right? So why the loss has occurred in this rear engine vehicle? Here it is. Since direction of which one? This is the direction of this vehicle movement. Yes, yes. So always vehicle movement is nothing but your front wheels direction only, na, that steering direction. So direction of this vehicle movement, direction of vehicle movement and the direction of what? Direction of vehicle movement and the direction of which one? This engine power are not same. Direction of vehicle movement and the direction of this engine power are not same, right? So because if you just observe na, up to this straight line portion, do you have any problem? No problem on the straight line portion. Only on the curved portion that problem comes into picture, na? Listen, where is that problem comes into picture? Curved portion, right? Here on this straight line, this is your front wheels direction, rear wheels direction, engine power direction also will be same, you can say, right? But in case of this, right, rear engine vehicle, na, engine power will be following the rear wheels path only. So like that, if you just observe, this is your front wheels direction, engine is producing the power in this manner, but vehicle is taking the turn like this, na? So this is by turning theta, so P cos theta, right? P is the power produced parallel to this rear wheels direction and P cos theta is a power utilized parallel to which one? This front wheels direction, right? So both can be same or both will not be same, you can say. If you just observe, both will not be same, na? That a turning angle difference will be there, right? Whenever this difference of this turning angle is there, right, both cannot be same absolutely. So this only will be resulting in which one? Which condition? Loss of engine power, right? Isn't it? Is it clear now? No. Clear everyone this one? Is it clear all of you? Right. Now coming to this 100. So what is it? 100, you can say, as the radius of this curvature, right, radius of this curve decreases, right, what will happen? Turning angle increases or not? As this is 100th point century, as what is that, you can say, radius. As the radius of curve decreases, whenever that's the radius of this curve decreasing, na, radius of this curve is decreasing, right, what is that happening? You can say, if you just observe, radius of curve is decreases, turning angle increases, right? More turning angle means, right, what is that, you can say, more loss, na? More deviation means more loss, na? Turning angle increases. When turning angle increases, right, what is that, you can say, when turning angle increases, what is that happening? You can say curve resistance also increases, na? Curve resistance also increases, right? Suppose if you just observe, this is your original straight line one we should have now. But at this place it is subjected to turning. This is your theta 1, and what is the radius corresponding to that? This is your radius r1 corresponding to it. Now suppose if you are having one more turning angle, let us say this is your theta 2. What is this radius? This is your chota bacha radius r2 na? Theta 1 is lesser than this theta 2, and what about the radius? R1 is greater than this R2 na? So radius and this turning angle are inversely proportional or not? Now curve resistance is directly proportional to this turning angle, but a turning angle is inversely proportional to this radius, right? So here from this what is that we can conclude? Curve resistance will be inversely proportional to the radius of this curve na? Curve resistance is inversely proportional to the radius of this curve or not? Definitely, right? Curve resistance will be inversely proportional to the radius of this curve. Definitely you can say. Got it? No. So shall we move to the next? Right, this is the story of which one? This curve resistance, you can say. Got it? Shall we move to the next chapter? This is your 7th chapter. Eighth chapter you can say it, that is your setback distance or this clearance or this versine. What is the symbol we are giving for this setback distance or this clearance or this versine, everyone? Small m is the symbol we are giving. Small m is the symbol we are giving, right? So this is what 101. Whenever it is for this single lane, whenever it is a single lane road na, first condition what is it? You can say sight distance is lesser than the length and the length is greater than the sight distance. So what is the formula? Setback distance m equal to r minus this r cos theta and r cos theta by 2 na, r minus this r cos theta by 2, right? This is, let us say, equation number 1. And how can you get these values? If you just observe among them that s is lesser na, so that angle is with respect to s, so s equal to that r theta you will be having. Therefore what is it? Theta you can get it s by r na. But if you want theta by 2, s by 2r, that is in theta by 2 radians. But if you want it in theta by 2 degrees, what is that we need to do? You multiply it with this 180 by this pi na, you multiply it with this 180 by this pi, you can say, right? Like that. Now second condition, what is that? You can say singly in second condition, sight distance is greater than the length or length is lesser than the sight distance, right? It's not possible now. Do you give guarantee that always sight distance is greater and length is lesser? No. Sometimes the sight distance is greater, sometimes the length is greater, you can say, right? So what is that? If you just observe that m will be equal to, what is that? You can say r minus r cos theta by 2 plus what is that? You can say s minus l by 2 into sin theta by 2 no? M equal to r minus r cos theta by 2 plus s minus l by 2 into that sin theta by 2, right? This is your second equation. Now here which one is lesser? L is lesser, so that angle will be with respect to this s or l? Angle will be with respect to this l, obviously na. Whichever is smaller, angle is with respect to that smaller one only, you can say, right? So L equal to that r theta, you can say. Then what is that theta? You can get it. Theta is nothing but your L by r na. So but we want theta by 2. Theta by 2 is nothing but L by 2r. But theta by 2 in radians you are getting. Theta by 2 in degrees, if you want, you multiply that L by 2r with 180 by this pi. Then you will be converting that into this degrees na. Now tell me, do you need to remember the first formula and the second formula separately, or if you remember second formula it is sufficient enough? Everyone, do you need to remember both, or if you remember the second formula it is okay? If you remember that second formula itself, that is sufficient enough na? If you remember that second formula itself, that is sufficient enough, right? It's not, that is sufficient enough, you can say, right? L by 2r into that 180 by pi. So here when it is positive na, s minus l is positive na, you keep it. Negative na, don't keep it. When s minus l is greater, positive. Here SC is greater than L means S minus L is positive, keep it. SC is lesser than L means S minus L is negative, don't keep the second term, right? Like that. That is easy only now. How to remember? Now 102. Only for single lane we require, or for this multi lane also we require? You can say for this multi lane also we require, na? For this single lane, if you just observe this diagram, this is your single lane, and what is this center line of this single lane, and from this is your which one, this object or vehicle, right? Between them setback distance is required, right? From the center line of this road, right? What is it you can say? This is your center line of this road, na? From the center line of this road to this nearest obstruction that is allowed is m setback distance. Okay, isn't it? What is the width we will consider? Width of this pavement on the horizontal curve we will consider it as capital B, na? Good morning, Pravalika. Right, isn't it? Coming to this, for multi-lane, right, what is it you can say? First condition, SC is lesser than L or L is greater than S. What is that you can say? If you just observe, what is that we'll consider? S lesser than L and this S greater than L, right? What is that? Everyone tell me. S lesser than L, what is that formula? That M equal to how much? R minus R minus D cos theta by 2, right? R minus which one? This R minus D cos theta by 2, right? This is equation number which one? This is 3, na? This is equation number 3, right? How can you get that angle then? Again, that angle will be with respect to the smaller one, S only, no? Same, S equal to, for single lane it is R theta, but for this multi-lane, what is that you can say? It is R theta or it is R minus D into theta, if you just observe. That is R minus D into theta, na? Then what is that theta? You can say S by R minus D. Theta by 2 will be which one? S by 2 times R minus D. That theta by 2 in degrees will be how much? That is S by 2 into R minus D into, what is it you can say? That is 180 by this pi we should have, na? That is 180 by this pi we should have, right? Got it? 180 by this pi we are having, right? Now here, what is the second case under this multi-lane? If you just observe, and m will be equal to which one? This m dash will be equal to which one? This m minus, what is it? M minus D, na? Yes. Now second case, what is the second case under this multi-lane? S greater than L, sight distance is greater than the length of this curve and length is lesser than the length. Tell me, anyone? Anyone tell me? I'll wait for your formula. Based on the same criteria, tell me that formula for this multi-lane is greater than L condition. Anyone tell me? Somebody? Pravalika, you just print from your brain whatever it is stored previously. Rishikesh, Pawan, Zamin Bhatt. L equal to R minus D into theta. What is that R minus D into theta? That is okay, but I am asking about which one? This is general formula, setback formula, not theta formula. Theta equal to, yeah, that is L equal to R minus D into theta. That is regarding theta, correct only, absolutely. But I am asking about this setback distance formula, main formula. Setback distance formula I need. So L is smaller, so we can make it as which one? This L equal to that R theta for this single lane, R minus D into theta for this multi-lane. Okay, that is fine. But setback distance formula I want. What is it? Theta equal to that L by R minus D. Theta by 2 is equal to that L by 2 into R minus D. If you want it in degrees, you multiply with this 180 by this pi. Setback formula, anyone? Anybody else? Yes, right. What is it? You can say here simply r minus, what is that? R minus d cos theta by 2. Just as it is, right? This is as it is, now this third formula as it is, plus what is that? It will come extra s minus l by 2 into that sin theta by 2 will come. Understood? This is equation number 4. Now tell me, do you need to remember all the 4 equations, or if you just remember this fourth equation, it is sufficient enough? If you just remember this fourth equation, it is sufficient enough now. So m dash will be equal to that, m1 will be equal to which one? M minus this d. Okay, m minus which one? D only, you can say. Now tell me, what is that d if you just observe? What is the d? Tell me. It is the distance between this center line of what? Anyone tell me? What is the small d represents? Small d is the distance between which parameters? It is the distance between which parameters? Tell me, all of you. Hello? Someone tell me. Distance between the center line of this entire road and the center line of what? Center line of this entire road and center line of which one? This is innermost lane. Na? Like that. Center line of this entire road and center line of this innermost lane, you can say. Got it now, everyone? Okay. Now here what is that m dash or this m1? M dash is equal to that m1 is equal to which one? It is a setback with respect to what? Center line of which one? It is a setback with respect to the center line of which one? You can say center line of this innermost lane. Center line of this innermost lane. What is that m? You can say, if you just observe, m is the setback distance from where? M is the setback distance with respect to center line of this entire road. Na? Center line of this entire road, that is m. M1 or this m dash will be which one? Center line of this innermost lane. And there is one more thing called as m double dash or this m2. What is that you can say? Setback distance from where? Setback distance with respect to inner edge of this road. Na? That is the inner edge of this road, you can say. Okay. That is inner edge of this road, right? Don't worry, I'll be showing all of them in this slide. In next slide, you can say what is m, what is m dash, what is that m double dash. In the I'll be showing it. Okay, don't worry. How can you get that m double dash or this m2? M double dash will be equal to that m2 will be anyone? Do you remember that formula for this m double dash or this m2? Anybody remembered or not? All of you. All of you remembered or not remembered? Anyone tell me? It is m minus how much? Yes, m minus this capital B by 2. Got it? M minus this capital B by 2. Now here, what is that d? You can get it if you just observe that d is nothing but your short formula I have given. B by 2 minus which one? This B by 2n. Na? B by 2 minus this B by 2n, you can say. Got it? Okay, I'll wait, don't worry. B by 2 minus this B by 2n. Not a tell me. Right? Done? Shall I move? Here, what is it you can say? Just for an example, 3-lane road I will consider for example. It can be applicable for any number of lanes, okay? But for example, I am taking the 3-lane road, okay? This is your, these are the 2 lanes we are having now. One second. Here, this is your first lane, vehicles are traveling like this, right? This is your second lane, vehicles are traveling like this. This is your third lane, vehicles are traveling like this, right? And sight distance on which one is important, right? Sight distance on this innermost lane is only important enough. Here, this is the center line of which one? This innermost lane. This is the center line of which one? This entire road, right? Because that side 1.5, this side 1.5, na? Right, center line of entire road. Right, now coming to this, from here to here we are taking it as which one? This is a sight distance, you can say. And from the center line of entire road to this one, na? That is your M, you can say. And from this inner edge, what is that you can say it? That is your M2, na? This is your M2. And from the center line of this innermost lane, right, what is it you can say? That is your M1 or this M dash, na? And what is this one? You can say this is your D. And what is this distance, right? This is your B by 2. If you just observe it, yes, now can we say M, from this M, if you are deducting this B by 2, are you not getting this M2? Yes, we'll be getting this M2, right? Is that clear, everyone? What is that B, what is that D, what is that B by 2, what is that everything? Yes, now. So this is also which one? This B by 2 distance only, right? Half width of the road, that side, half width of this road, this side. Clear, everyone? This is your which one you consider? 102. Now 103. So what is it for this 103? If you just observe approximate formula. So here this is your center line of this road now. This is your center line of road, and what is this one? This is your center line of which one? This innermost lane, na? This is the center line of which one you can say? Center line of this innermost lane, if you just observe, right? That is a center line of road, if you just observe, right? Got it? Now, center line of road and center line of which one? This innermost lane, you can see if you just observe, right? Now, so this is center line of innermost lane. From the center line of innermost lane to this nearest object, right? What is it? M1 distance, which distance? M1 distance, na? Is that no? Now, from this center line of, right? Center line of entire road to this nearest object, right? What is that you can say? This is Yamuna. From the innermost edge of this pavement, right? That is your setback distance M2, na? And center line of road to the innermost edge, it is B by 2. Center line of road to the outermost edge also, it is B by 2. Yes, na? Outermost edge to the center line of road, it is B by 2. Center line of road to the innermost edge, right? That is also which one? This B by 2, na? Got it now? Got it now? Is it clear? Now, so we are having this approximate formula. So what are these approximate formula if you just observe? Single lane, and it is for which one? This multi-lane. Single lane, what is the formula? First one, condition S lesser than L or this S L greater than S. For single lane, what is the formula? That M will be equal to, what is it you can say? S square by this 8R, na? And in case of this multi-lane, right, what is the S lesser than L formula? M dash will be equal to that same formula exactly, S square by this 8R. So single lane it is M, multi-lane you will be getting which one? This M dash, right? Then what is that M you can get from here? M dash plus D, na? Here M dash will be equal to that M1 will be equal to which one? This is m minus d. So m equal to m dash plus d na, m dash plus d. Second one, s greater than l or this l lesser than s. What is the formula for the single lane? M equal to, what is the, anyone tell me? L into what is it? 2s minus L by this 8r na, 2s minus L by this 8r, right? Corresponding to this multi-lane rate, what is it you can say? Same formula only, but it is given as m dash equal to L into 2s minus L by which one? This 8r, right? Got it? So m, how can you get with respect to center line? That m dash plus this d only we have to use it, right? Got it now, everyone? Everyone is clear? That is about your setback distance, right? Curve resistance gets over. Next is setback distance also gets over, right? Clear everyone, all of you, right? Once clear, no one wants to tell me. So short notes, this is itself your short notes, na? Yes or no? This itself will be your short notes or not? Once highway gets over, na, I'll be doing for surveying also, because surveying is running, na, surveying just started, right? Once highway gets over, I'll be doing for the surveying also, okay? By the time highway gets over, surveying half of the course gets completed, then we'll start the surveying, quick revision sessions and a live test. Then by the time surveying and next subject is strength of materials, some portion gets over, surveying will be over. So once surveying is over, I will be starting the strength of materials one. And like that. So, yeah, same like this pattern only. When next subject is half completed, by the time previous subject quick revision and live test gets over. Okay. Third subject, half of the subject gets over. Second subject, a quick revision and this live test I'll do. So that you will be in pattern of that one, right? You will be in the order of which one, revision and everything. Your revision will be done perfectly and live test, right? Because on your own doing is which is subject to start for structures, right? Engineering mechanics. Okay, shall I start with engineering mechanics then? I'll start with engineering mechanics after highway is over. Okay, no. After surveying is over, I'll start with engineering mechanics. Then after that, SWAM I'll go for. Engineering mechanics, just 3-4 classes will be enough, not more than that. For structural, you have to start with engineering mechanics. Then you go for which one? This SWAM. After that, you go for structural analysis. Then RC60. Right? That sequence is good to follow. Okay. Yeah, happy Holi, Deepak. Done everyone this one? Right. Next we'll be moving on to next chapter. Which chapter it is? This is 8th chapter, na? Ninth chapter, you can say. Transition curve, right? We make a heading and we'll start. So once we will discuss transition curves, this gets over, na? So obviously, right? This horizontal alignment gets over completely. Okay. Done? Heading is done, everyone? Now here, what is that part? 103 over, na? This is your 104. So for this transition curve, right? What is the property of this transition curve? Tell me mainly. What is the main property of this transition curve which is influencing the selection of shape of this transition curve and all those things? That the length of this transition curve is inversely proportional to which one? This radius, na? Length of a transition curve is inversely proportional to the radius, right? Means ls into that r will be equal to ls into that r will be equal to the constant only or not? Yes. right? Yes, it will reduce uncomfortable conditions, right? First of all, what is the purpose of this transition curve? You can say purpose of transition curve is what? Here if we just observe first one, what is it? You can say gradual introduction of what? What will be introducing gradually, right? Originally, this is the alignment with the sudden changes in the direction you are having. But what is it we need to do? We will be providing a horizontal curve here. Na? So whenever you are providing a horizontal curve, here this horizontal curve, just left side, what is it? Radius, straight line, infinite. Just right side, right, what is it? Finite radius r. Just left side, what is the centrifugal force? 0. Just right side, right, what is the centrifugal force? That full centrifugal force. Just left side, what is the super elevation? 0. Just right side, right, what is the super elevation? Full super elevation. Just left side, what is the extra width? 0. Just right side, right, what is it? You can say it is your full extra width, na? Isn't it? Full extra width, right? Got it? So like that, right side also similar way, na? Now, is it possible to introduce them all of them gradually in a single point? No, no. So for that, what is that we need to do? This is your original straight line and this is also the original straight line, you can say. For that, what is that we need to do? Tell me. We will utilize some straight line portion and we'll utilize some curved portion and we'll be providing a transition curve here and like that. Only at one end or at both ends this will do. At both ends we'll do it na. So at both ends we'll do this activity, you can say. So here everywhere on this horizontal curve, right, that shift will be same only, right? Whatever the shift you consider na, that shift will be same only everywhere on the horizontal curve. Alignment will be shifted in the downward direction, right? These are the ends of this transition curve. Like that we'll be having, okay? So here the shift will be increasing from the starting point. Now the tangent point is shifted to this location, right? This is another tangent point, you can say, right? Instead of this location it is shifted here. Instead of this one it is shifted here, right? This is your length of this transition curve, ls. Length of transition curve, LTC equal to that, ls is the symbol we are giving, right? What is this? This is your ls, length of this transition curve, right? Now what is this central portion, you can say? This is your length of this circular curve. The central portion will be how much, you can say? That is your length of this circular curve or not? LC will be your length of this circular curve if you just observe, okay? At the circular portion, that shift will be same, but over the transition curve it is different now. Now tell me, whenever you are providing the transition curve, right, how you are providing? We are reducing some length of circular curve, some length of some straight line portion we are reducing. From here to here, right, what is it you can say? This is your ls by 2. And from here to here, right, what is it you can say? That is your ls by 2. ls by 2, ls by 2, right? Yes, no? Got it? Right. Clear this one? This is only the transition curve. TC is nothing but your transition curve. Na? This is your TC. This is also your TC. Right? This is your CC. What is the CC? Circular curve. CC means circular curve. TC means transition curve. Right? Got it? Right? Note it and tell me everyone. Once and tell me. 999. I did not come actually. If I come, I would have told you now. It was planned, but I did not come actually. So some 3 4 days I thought of staying there, but it has not happened due to some personal work, some urgent work at home. I told no my 2016 student that she has got married. She has invited, but okay, I could not go there. Done. So what is the purpose? So this is your properties of transition curve. Right? What is the purpose of transition curve here itself? Yes, yes, I'll inform definitely. Purpose of transition curve is what? It is to introduce which one? It is to introduce this centrifugal force, super elevation, curvature, and extra width gradually. Na? Got it? These are all gradually will be introduced. Okay. Right. Now listen, tell me. At this point, tell me. Property and purpose both we are writing in the single point, 104 point itself. Right? Now this 105. So how can you get that length of a transition curve? You can say length of transition curve LS, right? This will be maximum of all the values, na? It is a maximum of all the values or not, right? What are the maximum of all the values, right? What is the first one? You can say based on this rate of change of centrifugal acceleration, right? LS equal to that V cube by this CR, na? Or you can also write it as this V cube by this JR or not? Yes or no? And what is it C or this J? You can say that is dA by this dt, na? Means a rate of change of acceleration. Which acceleration? Centrifugal acceleration only, right? And here what is the LS? LS will be getting in meters. R you have to substitute in meters. That is C we have to substitute in which units? Tell me. CR this is J. Acceleration already. Yeah, acceleration unit itself is meter per second square, na? By time is nothing but your second. So what is the unit of this J or this C? Meter per this second cube, na? Absolutely. That is your meter per second cube. What is the V unit? What is the V velocity or this speed unit? You can say that is your meter per second, na? Meter per second you can say. And what is the C value given as per IRC if we just observe? As per this IRC, that C will be equal to what is it? 80 by this 75 plus what is it? Capital V. Is it? It is not R. You have to be careful. Many people will confuse that R. It is V. Okay? 80 by 75 plus V. In our in my childhood means BTech. In my BTech time also I used to confuse with the same 80 by 75 plus R only I used to remember. Even I was also used to remember R. Many faculty used to say R also. That is a problem, but it is V, not R. Okay, you have to be careful. That is C will be in which one? This meter per second cube. This is your which one? This kmph. Okay, this is kilometers per hour, right? Kmph. Okay, and that C value 0.5 lesser than this C, lesser than which one? This is 0.8. So we have to allow the C value between these two values only, right? We should not allow beyond these. Now coming to this is second one, based on the rate of 80 by 75 plus R. Many people remembering like that. That is what. Okay. Instead of V, people remembers R instead of V. Okay. Second one, what is it? You can say based on the rate of change of this super elevation rate. Whenever it is the rate of change of this super elevation rate, what is it? LSC is equal to E into that N into what is it? You can say W plus this WE now. And LS will be equal to which one? This E into that N into what is that you can say? W plus this WE whole divided by this 2 now. When we have to use this first and when we have to use this second, tell me. When we have to use this first? New. Okay. NEW. Right. What is that? When we have to use this? When a rotation is with respect to what? When rotation is with respect to inner edge or this outer edge, right? For both conditions we have to use this only. And here rotation with respect to this center line we have to use the second one, no? Yes or no? LS will be getting in meters. EL, EN, they don't have any unit, right? W and this WE will be having which unit? Meter. Right? Got it now? Note this and tell me. So what is that C? C is nothing but your which one? This is the rate of change of which acceleration? Rate of change of which one? This is centrifugal acceleration. No? Rate of change of which one? This is centrifugal acceleration, or you can also call it with which one? Jerk. Or you can also call it as which one? This jerk. Right? Now, here, what is that n value? 1 by n value, you can say, if you just observe that 1 by n is nothing but your which one? This it is nothing but your rate of change of this super elevation. Na? Rate of change of this super elevation, right? So what are these values as per IRC? This will be taken as 1 in 100 for which roads, if you just observe? Urban roads, right? Now for rural roads, what is that? 1 in 150 taken for which one? This is a plain and a rolling terrain in this, in case of this rural roads, now plain and a rolling terrain. How much it is taken, right? 1 in 60 when it is taken, it is taken in case of this hilly and this steep terrain. Hilly and this steep terrain it is taken. These are all as per IRC only now. So first one is urban, means that these two will be which one? This is rural na? These two will be corresponding to this rural, if you just read. That is what. Yes. Next. What is the LS will be equal to 2.7 capital V square by this R. This is for which terrain? Tell me. Plain and rolling terrain. And that is taken equal to which one? This is a capital V square by this R. Na? When we have to use this? Whenever it is that hilly and this is steep terrain. Na? Whenever it is hilly and this is steep terrain, right, we have to use this, right? This is which formula, right? Who gave this formula? Tell me. Who gave this formula? Tell me, if you just observe. These are all IRC empirical formula, na? IRC empirical formula, you can say, okay? This is 105, okay? No. 106, what is that? Shift of curve. Shift of curve, what is the shift of curve? S equal to, tell me. LS square by which one? LS square by this 24R na? LS square by this 24R, right? Clear? What did you tell me? Clear everyone? Once clear, do it. Note it. Done. 12th point. What is it you can say? This is 107. Yeah, actually shift is nothing but your which one this originally this is your straight line portion and this is your circular curved portion, right? But what happens with the introduction of this transition curve, right? What happens you can say with the introduction of this transition, correct? This goes up to this point, na? Formula is blurred. No, no, no. See here, Deepak, what you do is you click on this screen and at the top right corner, right, that settings symbol, right, gear symbol is given. Click on that and click on this quality. Then you go for this advanced. Then you select which one. This at least 360, 360 or 480 or 720 you select. Then it will be clear. Okay. Okay, okay. I'll draw it in the next one otherwise. I'll draw it here. This is your original straight line one. This is your original circular curve. I'm considering one side only. Then what happens? This is the transition curve comes into picture. Na? Yes or no? Then after that, right, what happens? Again, this new circular curve comes into picture. Na? New circular curve, whenever you are providing, we have to provide it with the same radius as that of original, or we should change it. We have to provide it with the same radius as that of original. Here, this is the starting point of this transition curve, ending point of this transition curve. Starting to ending point, if you just observe it, how much it is that shifting? Okay, okay, formula in mind. Okay, right. Okay, Deepak, right? So here, alignment, if you are providing at the same location, is it possible to provide the transition curve or we have to shift it inwards definitely? Without shifting the alignment, is it possible to accommodate transition curve? It is impossible to accommodate a transition curve without shifting the alignment inwards, right? But if you just observe, from starting point to ending point of transition curve, that zero shift is increasing. And on the circular curve, do you have different shifts or same shift of the alignment through same shift of this horizontal curve throughout? Same shift of this horizontal curve throughout, na? But here these values are zero shift, you can say. That is somewhere here it is which one, this s by 2 shift, you can say. Somewhere here it is your 3 by 4 s, you can say, like that. Yes, here it is 0, like that. Shift will be increasing, na? Transition curve one end to other end, it is increasing gradually. But for this circular curve, it is the same, na? Shift of curve means that which curve, you can say it is for this circular curve only. Okay, understood? Shift of circular curve only, right? Got it now? Clear? Next, last point under this transition curve, 107. What is it, you can say? What are the three different shapes we'll be having? Tell me, if you just observe. What are the different shapes satisfying this transition behavior, everyone? What are the different shapes satisfying this transition behavior, if you just observe? This is your spiral, na? What is the next one? That is your Bernoulli's Lamin skate, na? Next, what is another one? This is your cubic parabola. Okay. So this Bernoulli's Lamin skate is also called with which name, if you just observe? Autogenous curve. What is the meaning of this autogenous curve? Automobile generated curve if you are leaving it freely. Now, what is this one? Spiral or clothoid or Glover's spiral. Now, what is this third one? Third degree parabola or this cubic parabola? Na? Third degree parabola or this cubic parabola. And what is it? You can say it is Froude's transition curve, right? Because that Froude fellow has identified that this is acting like a transition curve first, right? So you call it as which one? This is Froude's transition curve, right? Got it now? Now here, if you just observe the properties of these, right? What is it you can say? Properties of all these curves. What are the properties of these curves? Tell me. First and foremost one. For a deflection angle lesser than or equal to 4 degree. If you just observe, all the three curves are coinciding in the starting, na? Very small chota bacha deflection angle, right? So whenever it is for deflection angles lesser than or equal to 4 degree, what happens? Tell me. All curves have the same shape, na? All curves will be having which one? This is same shape, right? So do you have any problem if you are constructing anyone? If the deflection angle is up to 4 degree, do you have any problem if you are constructing anyone? No problem, no? Second one, for spiral. For spiral rate, what is it you can say? Rate of change of radius or curvature. Curvature is uniform throughout the length or not? Rate of change of radius or curvature is uniform throughout the length, right? Is it not advantageous? Throughout the length, same rate of change of radius is there, means it is absolutely advantageous or not? Is it is absolutely advantageous, you can say, right? Now, next one. For this lamine skate, if you just observe it, for this lamine skate, when you consider, right, what is it you can say? That the rate of change is what? Uniform up to which one? This 30 degree deflection angle, na? Up to this 30 degree deflection angle, that rate of change is rate of change of radius is uniform, right? But rate of change is which one? This is non-uniform, is not uniform beyond this 60 degree, na? Beyond this 60 degree deflection angle, you can say. Got it? Sorry, beyond 30 degree. Beyond 30 degree, it is having the transition behavior only, but non-uniform. Rate of change of radius means a rate of decrease of radius of rate of increase of radius, right? Rate of decrease of radius, na? This change is nothing but your rate of decrease of radius only. Okay? Note this and tell me. As the length increases, radius must be decreasing, na? As the length of this transition curve increases, the radius of transition curve must be decreasing definitely, right? Is it right? this and tell me. Right. 13th slide. What is that? See if you consider. Okay. Now here transition behavior, right? So what is it? You can say transition behavior is disrupted. At 60 degree deflection angle, right? What is the meaning of this transition behavior is disrupted at the 60-degree deflection angle? Radius increases na, after which one? This after the 60-degree, right? Radius increases after which one? You can say radius increases after this 60-degree. Like that. That is about your transition behavior, right? Lemon skate. Next, what is another one? Cubic parabola, na? Third-degree parabola or this cubic parabola, right? What is it you can say? For this third-degree parabola or this cubic parabola, right? What is the condition you can say? For lesser than or equal to that 9-degree deflection angle, what is that you can say? Rate, which rate? Mainly radius rate, na? Rate of change of this radius, na? Because once radius is changed, based on the radius only centrifugal force, so based on the centrifugal force on super elevation, based on the centrifugal force only that extra width will come to picture, na? Right. Rate of disrupted means disturbed, right? It is not. So means it means a non-transition behavior. Disrupted means not feasible, means it is not having the same behavior what we have mentioned. What is the behavior we have mentioned? If you just observe, length is inversely proportional to this arna. As the length increases, what should happen to the radius? Radius must decrease, right? That is the transition behavior. It is disrupted means as the length increases, radius also increases, right? That is what. Now, for lesser than or equal to 90-degree deflection angle, rate is which one? Rate of change is nothing but your radius decrease, na? Rate of change means rate of decrease of radius, na? Rate of change of radius is uniform, but with what conditions? Slow rate. Slow rate or small rate, both are same, na? No. Yeah. For this greater than which one? This is a 9-degree deflection angle. Same. Rate of change is uniform, same uniform only, but with which one? This is a fast rate. That is only the difference. Understood? So up to 90-degree deflection angle, rate of change is uniform, but a slow rate. Beyond the 90-degree also it is uniform only, but fast rate, right? So here as per IRC, what is it you can go for? As per IRC, for this road transition curve, whenever it is a road transition curve, right, which shape is preferred? Tell me. Shape preferred is which one? Tell me. Spiral, na? Spiral और दूसरा नाम क्या है इसका? Clothoid. Okay. Clear everyone? So this completes your which one? This is a transition curve, you can say, right? Okay, or this one, tell me everyone. Okay, right, got it. Now here tomorrow also will be having this. Tomorrow class at which one? Same 7:45 a.m. only. On which one will be going for? Horizontal alignment is over now. On this vertical element will be having the class tomorrow, right? Gradient, which one? Next one, summit and what? Valley curves, no? Summit and this valley curves, you can say. Got it? Clear everyone? Is everything clear enough you? Anyone having any doubt anywhere? Right. Okay, I'll be closing the session. Shall I close the session? Any doubts for anyone? Everything is clear, right? Thank you, thank you, thank you. Have a good day. Thank you, everyone. Right. I'll be closing tomorrow at the same time. We'll meet it, right? But in between, actually, I have to take 10 YouTube hours this month. Okay, so I think I'll do it. Okay, this Java design is over now. Then I'll be going for this materials or payment design, whatever it is. I'll do. Okay. Thank you all of you. Have a good day.